Hi, this is part 4 of the chucK granulator tutorial. In our previous tutorial, we went ahead and created a way to make multiple grains and essentially the basis for making a cloud, a granular cloud. Now what we'll do is we'll take that and randomize some of the parameters, and so we can play with different things and kind of shape the cloud and create different types of clouds using these fixed parameters. All right, so let's get started there. We'll keep all this code here. We're going to get rid of the gap in the duration right now because we're going to do some kind of randomization, and we're going to keep our while loop for now. What we'll do here is so that we can load per grain different samples, what we're going to do is we're going to create a bunch of strings. We're going to create an array of strings here and then send these paths really of our samples to various parts of the array. Okay, so if I have 4 samples, make sure that array holds 4, and then the paths to my different samples. I happen to have them all in the tutorial folder that you can download at the GitHub, and they're in the folder called samples, okay? But your path will be different. And then for the envelopes too, I include these envelopes as well. These are little tiny sound files that will have all the various kind of envelopes recommended by Curtis Rhodes in his book Microsound, and various others. I think I've picked these up here and there. Again, we'll have the number in our array, and then we'll have just a path there. Then we can load them later, okay? So I'll go ahead and copy all that stuff there and pop that up here above my while loop, okay? And this is essentially very similar to what we have, but now we're going to start parameterizing and randomizing some of the parameters, okay? So right there, to replace our just single reads, we can choose our envelope and our buffer by changing the number there. So if I want sample 0, it's going to grab that path and then load it into this buffs I up here, right? Same with the envelopes. Okay. Now we're going to do some various things just to parameterize, change things. Okay. So if we want to start with the position, all right, and we'll just have a little header for each one too. So if we choose our read position, we'll use the math library in chucK. And you can look that up if you want, and it'll give you all the different functions. And we're going to random 2. That means it's going to choose between 2 different positions, and it's going to be integer. If you want to float, you're going to have 2f like that. Okay, but since our position is going to be integer because it's to the sample level, right? So we'll just randomize completely what our read position will be. Okay, it'll be somewhere between the beginning of the sample and then buff side, and this is the one we've chosen. Samples. That means the total number of samples in that buffer. Okay, and then we're gonna chuck that to integer new position. All right, and we can do the same thing with all these other things: grain duration, amplitude, panning, playback speed. And so let's copy all those, and we'll kind of walk through those very quickly. But essentially the same kind of thing. We're just creating a random. Every grain is going to choose some kind of randomizations, and these are the things that you're going to want to play with eventually to create different kind of shapes and different types of clouds depending on what you want to do. All right, so the grain duration here, we're just choosing between 50 and 150 milliseconds there. I'm going to pass that to that variable. And then the gap duration here, and we're going to pass that there. I think I changed the name a little bit to gdur and grain gap. Okay. Grain gain, we'll just call it ggain. And then this is between, so each grain could be a little bit quiet or loud and stuff like that. You can change it. That's kind of quiet for a grain. Let's just go to 0.2 or something like that. So you get slight variations in loudness. You might want to choose a different approach to this, which we'll discuss a little bit later on. Like, so you could do swells and stuff like that. And then panning, I'll show you how we add a panner down there below. And -1 will be all the way left, and +1 will be all the way right. So we can just do a random panning. So each grain could be panned somewhere in your speaker, so you get kind of a full stereo effect. And then playback speed too. You can have them, playback in normal speed or what. Here I just have from backwards 2 times to forwards 2 times. Okay. Now, what we'll do here is we'll look here. Is now we're going to add all these various elements. So let's get it so we can see both. And here's if you want to just do a fixed number there, then you can just comment that out and uncomment that. So what we want to do is, if we look at our function and make sure that, so we added a couple things right here. So let's adjust our function. We added a couple things. Can't really see both. Oh well, let's see. Oh, is it going to do that for me? Ah, good. Oh no, it's not. Sorry. We just still need to see it like that. Okay. So let's see. We add position, dior, gain. So I have to add a couple things. We have rate. Dior, we have float, gain. Gain, and then we add a pan, and we already have a rate. Okay, and then our gain here, I think we already had a way to do it. No, I guess we dropped that at some point. Okay, so what we're going to do is we're going to add in our audio chain here, we're going to add a UGen called pan2, okay? And it's going to go pan2, P. All right, and then that's going to be chucK to the DAC. So this will be how we pan it. If P gets a -1, be on the left. If P gets a positive, if position P dot position gets a -1 or a +1, it'll pan it. Okay, and then we'll just add a gain here. We'll just add a gain here, and we'll chucK it to G dot gain, which I think we had at one point, and then we dropped it, I guess. Okay, oh well. And we have position, we have rate. And then we're going to add this one loop here, because if we start since we're randomizing our playback position, we start at the very end of the sound file, it'll loop around to the beginning. It won't just play like the very tail end. So we'll say 1, that means to loop, chucK it to buff.loop. Okay, that'll allow it to loop. And for position, that's all good, that's all good. Okay, good. All right, so then now when we spork our grain, let's just copy this. Let's copy all the, well, we know the envelope buffs. We'll just copy these new arguments, okay, so we can see them. Now, we have, and then we can look at all the various things that we have. Randomize, we have buffs M's, which is, chosen here. And you can randomize that number too if you want. You can have a bunch of different samples, choose from a bunch of different samples or different envelopes too. But I didn't do it in this case. I, and then we have position, so new post. Okay, and then we have the gain, which I called G gain, and then pan, green pan, and rate, and then Dior, okay, and then G gap stays the same. Okay, make sure we get rid of that so it doesn't kick an error. Okay, and so that's how our function looks now. We've updated our function with a panning, and we've added the loop, and we've added a gain. So I didn't cast that right, or chucK that right. Okay, a little typo there. And then when we spork our grain, it just reflects our new function and a couple additional arguments. And then we have our randomization here. So here we're just randomizing position, randomizing duration, et cetera, et cetera. So you get more of kind of this full grain. And this is just continuing on forever while true, right? So let's see how that sounds. All right, it's already sounding more like granular synthesis. Later on in this tutorial, we'll do some sample clouds and we'll just adjust some of these parameters. But for the time being, you can have a play with that.